Hello everyone, this is Namrata Rana, your chemistry educator. In the previous video, we have learned about the esterification reaction. And this video brings you the questions of esterification. And before jumping towards the questions, let's see another term related to esterification reaction, which is isotopic labeling. You will see this word in your textbook whenever there is esterification. What are isotopes? Actually, isotopes are the compounds, or isotope I may say, these are the atoms of the same element. Suppose you have oxygen atom of the same element which have different atomic masses. So oxygen has two type of isotopes, that is 16 oxygen and oxygen 18. So what does isotopic labeling does in esterification reaction? Actually, it tells you about the OH group. As you can see, water has hydroxyl group. Now this tells you, it gives you the confirmation that this hydroxyl group is from acidic part or from the alcoholic part. As you can see, this OH is also present in this acidic part also, as well as in this alcoholic part also, right? So it confirms that OH part of this water is coming from, can you say, is coming from this acidic part. So if I label this oxygen atom as 18, suppose I'm labeling this one of the hydroxyl atom of oxygen by 18. So this oxygen atom will appear in water. Am I correct? Because COH bond is cleaving. COH bond is cleaving, and in alcohol, it is the OH bond. It is the breaking of OH bond. So vice versa, if I take this oxygen as 18 oxygen, that is the alcoholic oxygen as 18 atom, can you tell me which of the oxygen atom is visible in the product side? So we know this OH will cleave and this OH will cleave like this, right? So this time, which of the oxygen is 18 oxygen? So this time we'll see OH is this one, correct? Because the OH group of water, what I'm saying, the hydroxyl group of water is coming from your acidic part. So acidic part has oxygen 16. So water will also show oxygen 16. It is not it's not necessary to label this oxygen as 16. It is confirmed that if we write oxygen without labeling it as 16, it is considered as oxygen only. Correct? So I hope it is clear, isotopic labeling. Now moving towards the questions of esterification reaction, and these are the questions of the previous year, correct? Now esterification reaction, you need to see the applications of any reaction, that is in which form you will be seeing that question or this part in your exam. So if I talk about question number 1, which of the following will have higher rate of esterification reaction? In this reaction, there are two alcohols given to us. Just make the structure. We have methanol as, what is the formula for methanol? CH3OH. Am I correct? And second one is propane-2-ol. Prop stand for 3 alcohol, 3 oxygen carbon atoms, and we have alcoholic part on the second carbon, correct? Right. Now, what is the approach for this question? You need to see the intermediate part. If you remember, intermediate part of the mechanism. So if you remember, you have intermediate as RCOH and OH. With this, we have our alcoholic part connected to it. I'm correct, right? So for any reaction to be fast, it is asking about the rate of reaction. For any reaction to be fast, you need to see the stability of this, you need to see the stability of this transition state. Now, transition state stability depends upon the steric hindrance. It depends upon the steric hindrance. Steric hindrance is actually the crowd. What is the crowd? Means if these R groups, these two R groups are bigger in size, so there would be so much crowding in it. It would not be a stable transition intermediate. Correct? Transition state would not be stable if R groups are bigger in size. So for any reaction to be fast, you need to see the stability of the transition state, and stability of transition state indirectly depend upon the steric hindrance. So smaller R group will have greater rate. If you see these two alcohol, you are seeing that this contain only one carbon atom, whereas this alcohol part contains 3 carbon atoms. So I hope you got your answer. So answer would be methanol. So in this case, we'll have methanol as the correct answer. Similarly, for the acidic part also. Now this transition state involves R group of an acid and also R group of a base. Alcohol. You can call it a base also. Correct? So similarly, when you write the structure of these two acids, formic acid is HCOOH and acetic acid is CH3COOH. So smaller acidic group will have greater fast of reaction. As simple as that. Moving towards the second question. What is it given? It is given an acidic part, alcoholic part, and H positive ion. See, you will not be given as write down the esterification reaction. You need to see that if an acidic part is given right, in front of an acid, you have an alcohol in presence of acid. So it should strike in your mind that yes, it is esterification reaction. So in esterification reaction, what actually happen is you need to cleave this OH bond. You need to cleave this H bond of alcohol. You need to make an ester. So ester is HC double bond O of this acidic part, and alcoholic part will give you oxygen 18 and CH3. Leftover part is water. Am I correct? You need to see this isotopic labeling also. In the second question, you have acidic oxygen as O18 and you will cleave this bond. Am I right? So in this question, you will get CH3C double bond of acidic part and OR group O CH3 of this from alcohol. You will have water, but this time this oxygen is coming from acidic part, and acidic oxygen contain oxygen 18, so it will be seen in water molecule. Next question. Now this is a type of diol. Diol means which contain two OH group adjacent to each other, that is alpha and beta alcohols. Now you have two alcohol molecules, OH and OH. Also you have two molecules of acetic acid. So what you need to see is it is given 2:2 or 2:1 or 1:1. I hope you are getting it. They are two OH group, correct? And there are two acidic group. So all of the OH and COH, OH and COH will give you ester. So this time you need to cleave this. You need to cleave this acidic part OH and you need to cleave this OH of your alcohol, correct? So we'll be getting CH3 C double bond O of acidic part, this acidic part. You'll connect oxygen, this oxygen. Talking about this oxygen. To this oxygen, we have connected CH2. Then this CH2 is connected to another CH2. This CH2 is connected to oxygen and which is further connected to your C double bond O CH3 part. So this is the ester which is going to be formed, plus 2 molecules of water are released. Remember, there are 2 molecules, correct? seeing the fifth question. Fifth question includes the acidic part and the alcoholic part within the molecule, that is intramolecular esterification reaction. So this time the reagent formed or the ester formed would be an cyclic ester. What you need to do is you need to cleave this OH bond and you need to cleave this OH bond of alcohol. Now, if I write this C double bond O connected to this carbon, similarly the next carbon, next carbon, next carbon, then an oxygen atom. And this oxygen is connected to this carbon atom. So this is a kind of cyclic ester. Plus one molecule of water is released. Correct? Now moving towards the next question. Now see, there are 3 molecules of OH and only 2 molecules of acidic part. Now you need to convert only 2 OH into esters, but you need to see which of the OH would be converted. Now if I talk about this, the middle OH group, it is sterically hindered, so it will not be a favorable position for the attack. Correct? So 2 positions would be the outer position, that is the terminal position. So we need to cleave this OH bond and this OH bond. You need to cleave this COH bond of the acid. You will be getting CH2O, C double bond O and CH3. This CHOH remains as it is because there is a ratio of 3:2. So you need to select the 2 OH groups. Again, this O to this O, you need to add this acidic part, which is this. And 2 molecules of water are released. I hope this is correct. You're getting it? Correct? Now, see, next question. This is a ratio of 1 and acidic part are 2. So you need to cleave this OH group. From this, you can cleave this, any of this, because this is same. This is oxalic acid. What is it? Oxalic acid. So oxalic acid plus methanol in presence of an acid will give you C double bond O, this CH3 and connected to COOH. Right? So these were the important questions of esterification reaction. I hope you have got all of them. If there is any doubt, you can comment in the comment section.